34, question 34. Okay, the diagram below shows fruit P. Don't know what on earth is it, but it's a fruit. Sam concluded that the flower from which this fruit is developed has many ovules. Do you agree? So the first thing first is ask yourself, what are ovules? So your ovules, right, they basically contain your female egg cell, and each ovule has one, which I've explained many times. Okay, so the first thing you need to say, do you agree? Your answer should be yes. Okay, and then after that, why? Because fruit P has many seeds. Since each ovule can develop into one seed, this fruit must have many ovules. Okay, so there must be some form of a relationship. You have to put it there. Okay, so fruit P has many seeds. This is the evidence, and then you go on to explain the ovules of a flower develop into seeds. Okay, next. Based on the diagram above, identify and explain how two characteristics of fruit P helps the fruit to be dispersed widely. Now, there are altogether 3 things that you can talk about. Okay? Now, what are the 3 things? So let's take a look. I will group them for you. So, one has got to do with the fact that, it is not digested. The second one has got to do with the fact that it can be swallowed. Alright? And then the third one is talking about it being attractive to animals. So, those that are attractive to animals, okay, I will highlight it in green. So the bright red skin actually helps to tell the animals that, hey, something juicy, something nice is here. It helps to stand out against the green foliages of the forest. Think about that. Usually leaves are green, right? But if you want it to be attention seeking, you want it to be an outstanding color such as red color, so that the animals can see it easily and it can attract. Okay? Then after that, your sweet juicy flesh is also for attracting the animals. Alright? So therefore, you can choose to write 1, talking about your bright red skin, or 2, okay, talking about your sweet juicy fruit. Now, there is a third answer, which I'm going to highlight in yellow. Small indigestible seeds. These two comes together. Now, the small part allows your animals to swallow the seeds easily. Okay? Not for fun one. So many of you say things like swallow. That's it. It's not just swallow, but to swallow it easily. Alright? On top of that, the indigestible seeds will tell you that you can pass through the digestive system at another location. So, what can we say? So, characteristic 1, your bright red skin. Okay, it attracts animals to the fruit to eat it. Okay, or it allows the animals to see it clearly or easily to eat it, to find it easily. Okay, so these are all plausible answers. Now be very careful. Y'all don't use the word attract. You will say it allows the animals to eat it, or it I can't exactly remember what most of you say, but the word attract is not there. So you need to put in that keyword attract. Okay? Now the second one, I'm going to write for you the other one, the less common one, which is the small indigestible seeds. This is another characteristic. So remember, okay, allows animals to swallow it easily. This is very important, the word easily, and pass it out at another location. So when you think about it, the pass it out at another location talks about the indigestible seeds. Okay? The part about it being swallowed easily explains about the small. So some of you may go, Mr. Chong, I don't understand. Why must it be easily? Well, flip it around. Can you still swallow it if it's not small? Actually, the answer is yes. But would it have been difficult? Yes. So what it means is that instead of swallowing, the animals would prefer to spit it out. You realize that? Okay, between swallowing, the other alternative is not swallowing it because it's difficult to swallow. So by being small, it makes it easier to swallow. Okay, now another thing that I need to caution you students is that when you talk about this part about attracting animals, right, you'll just go, oh, fleshy meat of juicy flesh attract animals, full stop. Don't have the behind part. Then my question would be, attract the animals to do what to it? You know what I mean? To juggle the fruits with it? No, literally, you really need to tell me it is to eat it, right? So many of you did not tell me for what. You just go attract the animals. Next. This is a very common question. We have to get this right. I'm going to revise with you in great detail. There is no way you're getting this wrong in exams. Please stop it. Now, this question, straight away, right off the top, even before reading the question, I know Mr. Chong is going to nag me. This is on electrical circuit. CEO must come out. Okay, even before reading the question, the first thing that comes in my mind, C stands for, okay, whether my circuit is closed or open. Okay, E stands for whether or not my electric current can flow through. O stands for what is the outcome. Now the outcome depends on the question. Okay, what do I mean by that? So if the question in the circuit, there are light bulbs, then the outcome would be whether or not the bulbs are were lit. If the question is on, like for example, this question, electromagnet. So then you have to tell me whether or not the rod with the coils around it becomes an electromagnet and then whether or not it attracts anything. So this one, I cannot predict one, you know. But at least for these two, it's a given. You must. As long as you answer this question correctly, you should get the marks. If you take a look at your paper. So E, so when I tell you you're missing E, it means that you're missing the electric current part. So let's jump in. Harish set up an electric circuit as shown below. When he closes the switch, okay, the rod moves and hit the bell. So where's the rod? This is the rod. So when he ons it, this part actually shifts, right? And it hits the bell, causing it to ring once more. So even before I read on, I will try to make sense. Why would that happen? So trace. For all electrical current, trace. So positive end is the longer one, the shorter one is the negative. Electric currents always flows from the positive terminal to the negative terminal. So this way. So I know it will go through here, it will pass by here, so it will close. Now as it passes by here, this becomes an electromagnet. So with coils around an iron bar, I know that this will become an electromagnet, probably, as long as the circuit is complete. So when it becomes an electromagnet, this is an iron rod, this will be attracted in this direction, so therefore it will hit the iron rod. Okay? Now, what will Harish observe about the iron rod after the bell rings? Explain your answer. So after the bell rings, that means after it has happened, this has happened. So you must think, so at this juncture when it's happened, trace. There is a gap here. Do you not notice, people? Okay? And a lot of you actually start talking about things that are not necessary. For example, you start describing about what happened before it closes. No, it says after bell rings. So straight away, you use CEO. So if I'm going to structure it for CEO, it tells me that I need to talk about how, okay, the circuit is open, right? So you need to say that the circuit is open. Okay? Thus, iron bar X is no longer. Oops, sorry. Can I go back 1 second? Because I want to make sure that I use CEO to help you all. Okay, I'm going to color code this. Alright, let's go again. So the circuit is open, hence electric currents or electricity cannot flow through the circuit. Now, many students will miss out this point. Through the circuit. In exam, I can almost tell you that we will give you the marks. But it does not make sense. Flow through where? I don't know where. You understand what I'm saying? So you tell me the circuit is correct. You know why? Because every component is part of the circuit. The examiner cannot fault you. Yeah, what? It's true, there is a gap. I cannot flow through a circuit. So be it the bulb, be it an iron bar, be it anything, if you put the circuit, it won't be wrong. This is actually good practice. So please do not try to save on your words. It will save you. It will literally save your skin in certain questions where they require you to see that. Okay? Next. Then after that, your C is done. Your E is done. Okay? What's left is your O, your outcome. So how will your outcome look like? So then, okay, iron bar or task iron bar X is no longer an electromagnet and cannot attract the iron bar, and cannot attract iron rod, right? And then you go on to say the iron rod will return to its original position. Okay, so this is also important because this is the one answering to what will he observe. And this is your O. So CEO. So can you see how it's structured so nicely? Something that I taught you is being applied in a past year paper. So this tells you that you need to know this. Okay, next. Harish replaced iron Y with a wooden bar. How would the bell ring? Will the bell ring, okay, when he closes the switch? Explain your answer. Now, in this case, you need to be very careful. A lot of you have this misunderstanding that they're asking whether or not this is a magnetic material. No. They are asking whether this is a conductor of electricity. Why? Because even if, so in exam this is what happens, you need to ask yourself, even if let's just say I replace this with a magnetic material, will it really guarantee that it works? So in this case, they're not asking about that. The whole point about it is electric current needs to flow through it. Okay? So therefore, it's talking about conductors of electricity here. So once again, CEO. So how do we do it? No. Wood is an electrical insulator. Okay, I need you all to be very clear. All eyes on screen. This is so important because as I was marking the prelim papers, this came out as a serious common mistake. Very. You need to tell me that it is an electrical insulator. You cannot just say insulator. Insulator of what? You cannot also tell me that wood is not a conductor of electricity. So if it's not a conductor of electricity, then what is it? You have to say wood is an electrical insulator. You understand? You need to be specific. I must see the word electrical. I must see an insulator. Or if you cannot spell, you must say wood is not an electrical conductor. Okay? Of electricity. Alright? You have to be very explicit. Okay? Hence, okay, electricity or electric currents cannot flow through the circuit. Okay, so CEO. Now, the other alternative answer is talking about how the circuit is actually open. So that's O. So in this case, because it's only worth 1 mark, okay, we are only giving marks for electrical insulator, half mark, and then half mark for your either your E or your O. So either you tell me that the circuit is open or electric current cannot flow through. But once again, the CEO will apply. Next, without changing the bell or the rod, suggest one change Harish can make to the setup so that the bell will ring louder. Now, some of you actually say, oh, move the bell closer. To what? I don't know. Okay, is just move the bell closer or move the bell further. Okay, so your thinking is if I move this bell closer to this side or move it that side, it should affect the volume. But in theory, that could happen. But it also means that, okay, we don't know because that is really something that needs to be experimented, and there's a lot of debatable circumstances. Okay, what is true is that they want you to realize that when you actually increase the number of coils around your iron bar X, it also makes this a stronger electromagnet, which means that in theory it should actually attract your iron rod with a greater force, allowing it to hit your bell harder. You realize that? So the whole point about it is how do you get this to become a stronger electromagnet? So one way is to talk about the coils around it. The second way is to increase the number of batteries. Now, here's the thing. When you actually talk about adding the number of coils, you cannot say add more coils. You must say add more wire or wire coils around iron bar X. Because when you say add more coil, to where? To here, to here, to here, to here, I don't know. If you don't put that there, you don't get the marks. I'm serious about this. We are very sticky about it. That's one. Two, add more batteries. Some of you just go add more batteries. Add more batteries to where? Add how many batteries? Okay? So you can say add more batteries to the circuit. So please do not use vague things. And if you want to use a more powerful battery in your own terms, you can say use a battery with higher voltage. But the golden answer for this two will be to add more coils or add more batteries to the circuit. Okay? So I'm going to write down for you. So adding more coil or wires around iron bar X, or add more batteries to the circuit. I want you to be that explicit. Remember, in exams, we always do not want to give the examiner any reason to doubt our answers. Right? Next, let's take a look at these. Okay, study the circuit diagram below. Okay. Bulbs B1, B2, B3, B4, B5 are all identical. If switches S1 and S2 are closed, which bulb will light up? There is only one way to do this, and that is to trace. So I strongly suggest that you have a pencil with you, okay, that you can indicate that your 1 and your 2 are closed. And then you trace. And every time you go past, okay, you actually would want to put a tick. So this is what I would do in an exam setting. I will go, okay, straight away I know that this is a gap here. So basically, okay, I know that since it cannot flow past here, anything that is, okay, here and here, these two are a goner. Okay, so I know that it will flow through here, 1 complete, 2 complete. Okay, I know that then this and this and this will light up. Okay, so answer B1, B2, B3. Now, students tend to be quite careless. You need to state exactly what the question says. If they say B1, B2, B3, you put B1, B2, B3. Some of you will just go 1, 2, 3. 1, 2, 3 is what? I don't know. When all the switches are closed, if B4 is blown, which bulbs will still light up? So in this case, same thing once again. Close everything, and then after that indicate somehow that this is actually a gap. And then trace, okay, to see if you manage to get a complete circuit. So I know that my 5 is okay, my 3 is okay, my 2 is also okay, my 1 is also okay. So based on this, I know that everything else would remain lit. Okay? Then they ask you, which bulb will still light up? Explain your answer. So why is it that they are still being able to light up? So in this case, they're not asking for arrangement, but it's okay if you tell me that they are arranged in parallel. That's fine. Okay, all fine and dainty. But do you realize something? This B4 over here is not really in parallel with B3, B2, B1, you know. Do you realize that? So if let's just say it was this way, then yes, probably it's parallel. So in this case, they are not asking you to compare something that is parallel with something that is arranged in series. But if you have written parallel, don't worry, I'm not subtracting marks. But what I'm trying to tell you is that the key idea here is, why are they still able to light up? And it goes back to the key principle of C, E, and O. Right? So I have to explain to them, firstly, okay, which light bulbs? My answer would be all other except for. So B1, B2, B3, and B5. And then I explain using CEO. So because the circuit or their circuit is still closed, right? Electric current can still flow through. outcome. Therefore, they remain lit, or therefore B1, B2, B5 will light up. So let's translate that into an answer. So B1, B2, B3, and 5 will light up. Okay, why? There is still a closed circuit for B1, B2, B3, and B5. Therefore, electric currents can still flow through the circuit for B1, B2, B3, and B5. Right? So my CEO is here. My O is actually here. E is here, and C is here. Alright? Next, moving on. Ines set up an experiment to find out how shadows are formed on the screen as shown in the setup. Without changing the size of the book, state one option that Ines can take to increase the size of the shadow. Okay, there is a trick to this question. All eyes on screen. I am going to teach you something, okay, that will help you remember in exam. Okay? So what you do is this. In exam, if you cannot remember, you draw a straight line. Okay, flat or whatever it is. Okay, and what you do is that you actually would have a light source. I'm going to use orange for my light source. I'm going to just put it here, one dot. And then after that, I'm actually going to draw an object. I'm going to use an object. Say this is, I don't know, 1 cm or whatever it is, doesn't matter. And then I am going to draw a blue color from my screen. Okay. Now, in exam, right, what you can do is, you can use this method to actually determine, okay, how big, okay, what happens when the different objects are moved differently. Sorry, let me just erase away this screen. This screen is not tall enough, I must say. Okay, something like that. Okay. Now, watch what happens. If I were to move my object further away from my light source. Light source is this one, orange color. So if I move it away, it is over here now. Okay? Now, what do you realize? Okay, sorry, I realized I did it wrongly. If I move it further away, must be same height, okay? You will realize that as I move it further away, I'm going to use red, blue color to signify the second one. What happens? The shadow becomes shorter. The initial shadow was this height, larger. This is your screen. Maybe I should label it for you. This is your screen, and this is your light source. Okay? So your object is in red. So you take a look at it. So this is original, right? Originally, I put my object this close to my light source, and I draw a line. The height of my shadow is like this size. But as I move my object further away, can you see? First position, second position, same height. Then after that, I draw again. My shadow become this height already. Okay, and then after that, if I were to move it even further, closer towards the screen. Okay. What happens? It becomes even shorter, smaller. So in exam, you can use this to play around to help you determine should you move nearer or further away from the light source, the object, or towards the screen? Okay, so you have to describe the object in relation to somewhere one, the positioning. So you can say, oh, move further away from the light source, or move nearer towards the screen. But my whole idea is there must be some point of reference when you talk about your object moving, okay? Either shifting closer to the light or shifting closer to the screen, depending on the question. So let's take a look at it. So without changing the size of the book, exactly what we did down here, state one action Inez can take to increase the size of the shadow. So now I want it bigger. So from here I know already, if I move it in this direction, closer towards the book, okay, my shadow becomes bigger. Correct? Using this example over here. So I would like you to actually watch this video again to actually help you to remember how to do this in exam, just in case you really get confused. Okay, so I can either say move the book closer to the light, or I can say move the book further away from the screen. Either one, the answer would be correct. Okay. Now take note, sometimes you need to fix, they may shift the light or they may shift the screen depending on the question. So move the torch closer to the book, or move the book closer to the torch. Either one. Okay? Clear? Next. Inez then replaced the book with a metal ring. The metal ring is placed very close to the torch. In the space, draw the shadow that will be formed on the screen. Actually, what they want you to draw is basically something that is of the same shape. That's all. You all are overthinking. So what I'm looking for is, number one, must be drawn in pencil. Okay, number two, it has to look like a circle. Number three, in terms of thickness, it should be more or less relatively the same in proportion to whatever this is over here. Some of you, you're being too ridiculous. You draw it like this, and then you draw it so thin. I mean, come on, that's not right. That's not the same shape. So it has to be in proportionate. Then after that, most importantly, I need to see shading. So line shading is fine. So as long as I see some form of shading, okay, I understand that you have shaded it, fine. Okay, I get it. But some of you just left it without the shading, and that's wrong. I know that you all cannot draw a perfect circle, but try your best. And then some of you, I don't know what are you all doing. You all did this. This is not Picasso, you know, it's art, you know. And then I almost wanted to do this for you all. Okay, no, it's not funny. I was like having such a horrible time marking this. Next, listen very carefully, all eyes on screen. I want to actually show you how do you draw light rays. Obviously, you have forgotten. It's absolutely horrendous. And the first thing first, most of you get the fact that it needs to be reflected. Number one, all light rays must be perfectly straight line, because light rays travel in a straight line, they do not bend. So if you look at your work, you will realize that some of your work, okay, are totally crooked. It should come from the light source. Please use a pencil. I cannot stress this anymore. But I don't know why students just simply refuse to listen to me. So it should be a perfectly straight line. It needs to hit the object of whatever that is reflecting. So in this case, they said, okay, balloon, right? It needs to touch the balloon without any gaps. And then you never break. Okay, so some of you like to do this. No, there is a gap here. I do not want this. So it should be continuous. Okay? Okay, it needs to join perfectly to the eyes. Okay, it needs to be like this. And then how do you draw arrows? Some of you put the arrow here and then put the arrow here. I cannot see. You're blocking the line but to show that it reflects. So your arrows should be here like this. Two arrows. Some of you, I don't know how many arrows you want to put, I don't know how many arrows, no need. Just one arrow, one line. That's about it. Okay? That is how you draw light rays. Next. Okay, this question also cannot get wrong one. A very simple condensation water cycle question, very standard. Okay? Jia Min conducted an experiment with two identical beakers, L and M. The beakers are filled to the exact same amount of water at different temperatures. So this is your change variable. Okay. Alright. They were then left in the science lab. After 10 minutes, Jia Min observed water droplet forming on different parts of the setup. Now, right even before I jump in, straight away I know this is a water cycle question. And I also know that the part where I see my water droplets forming is the surface that is the cooler surface. That means this must be the warm and then this must be the cooler surface. No need to see already. The part that I stress again, the surface that I find the water droplet on would be the surface that is cooler. Okay? And then the site, if there are two regions, the site where you actually find your water droplets is the site with the warmer water vapor. Okay? As simple as that. I don't even need to study that much. Complete the table below to show the correct temperature of water contained in each beaker at the start of the experiments. So think about it, as I told you already. The water droplet is on this side. So this tells me that this side over here must be the one with the warmer water vapor. So if this is the warmer water vapor side, then this side must be the cooler, right? So basically this is the 10 degrees Celsius. Okay? And then after that, over here, same thing, because there is no condensation in the water at all. Okay, on the surface, there's no condensation surrounding this area where the water is in contact with the glass surface. This tells me that the temperature of the water must be higher than room temperature, okay, or same as room temperature. So this must be the 85, because there's only two plausible answers, either 10 or 85. So answer 10 degrees and 85, that's it. Why do we not need the degree Celsius? Because they already put here degree Celsius. But it's okay. Nothing wrong. Explain how the water droplets are formed outside beaker L. So this is basically, I see water droplets, straight away I know that it is condensation. Right? Ta-da! Condensation. So for condensation to happen, I must have a source of water vapor, because the definition of condensation is actually water vapor touches cooler surface, loses heat, therefore condensing into liquid water droplets. Wow, I actually gave you the whole answer. So all you need to do now is to identify where is the source of water vapor. So I always tell you all this. If there is a cooler, there must be a warmer, because it's a comparison. So therefore, warmer water vapor from the surrounding. How do I know? Because it's here, ma. What else could be outside? Surrounding, right? Okay, so warmer. A lot of you did put the word warmer. Warmer water vapor from the surrounding air outside the beaker touches or came into contact. I know some of you don't like the word touches. Fine, came into contact. It's just that came into contact is a lot more work. With the cooler, I must see cooler outer surface of beaker L. Lost heat and condense into water droplets. Some of you also did not put condense into water droplets. You have to put water droplets. Why? Because there are certain questions that require you to explicitly state that. So it's good practice. Practice makes habitual. Please put the water droplets. Don't say, I never say. Okay, so where is the source of it? Came into contact, cooler surface, lost heat, condense. Many of you did not put lost heat also. Next, suggest one way to increase the number of water droplets formed inside beaker M. Take note, the one way, right, you have to tell me the method. You cannot be just increase the temperature of water. So what you want to do is, you basically want to increase rate of evaporation because you're talking about inside, M, we're talking about M here. So inside, so how can you form more water droplets over here? So the only way is to have more water vapor. How to get more water vapor? You basically want to increase rate of evaporation. How do you increase rate of evaporation? Remember the three factors, WET, wet, temperature, exposed surface area, and the last one is wind. So obviously you cannot put a fan inside here, okay? And you do not want to change the beaker. So the best answer is actually how increase the temperature. So you want to increase that, but must tell me how. So you want to add a heat source. Okay, add a heat source, okay, under beaker M. Right? So please, I need this method. Okay? I do not want to see things like increased temperature. Okay? So increased temperature is more on explanation why. So you add a heat source under beaker M to increase the temperature of the water. You know what I mean? So the increased temperature is explanation. Then after that, another alternative that you can do is to put ice cube at the top here. So what happens is that when you put ice cube at the top here, you're increasing the condensation rate. Why? Because heat will be lost from your water droplets, from your water vapor to the cooler surface at a faster rate. Because this part here would then be colder. Okay, so there are two main ways. Either you increase rate of condensation or you increase rate of evaporation. Alright? Next. Okay, the diagram below shows the water cycle. Once you see water cycle, you know evaporation and condensation. The arrows represent the processes that take place in the cycle. Identify W and X. So, in the first place, if I were you, I'll write down the state. So clouds are actually made of water droplets. So this is actually water droplets. Okay. So how do you get from water vapor to water droplets? Straightforward answer, condensation. No need to think. Okay. And then after that, we have what is X. X is, this is actually liquid water, right? Liquid water. Okay. Now, how do you get from liquid water to gaseous water vapor? Evaporation. Now, then the question asks you, what is the difference between two processes? Okay, now some of you tells me that, in condensation, you get water. In evaporation, you get water vapor. But then again, you think about it, water vapor is sort of like water, just that it's in gaseous form. So really, do not write that. What you meant to say is that you get a different state of water. So if I were you, I would say that in condensation, you would get gaseous water vapor. However, in evaporation, oh sorry, let me rephrase that. In condensation, you get liquid water. In evaporation, you get gaseous water vapor. Right? So that's what you want to say. I need to see the word gaseous and liquid if you want to put that point. But there is another point you can say that, okay, process W involves heat loss, but process X involves heat gain. Okay, the next answer you can be process W is a change of state from gaseous to liquid, but process X is a change of state from liquid to gaseous. Alright, so with that